Hi, this is our team presentation for Lesson 8. My name is Jason.
And my name is Ken.
So first we'd like to talk about the 7 steps of functional development process. The first step is clearly define the problem. So together as a team, we create a development document that goes over all of these steps for each method. In the first one here, we need to define the problem. So we have bushel of wheat is the currency in the game. The price of land is a random value generated by the game. And so after we add all of these together, we come up with an algorithm that's S equals S minus P times N. And so we go to start programming all of that.
And that's what we use this test matrix for. So the test matrix is another way to view the problem that we have. So we have our inputs right here, which are acres to buy, land price, acres owned, and wheat in store. And so right here, we're looking at a valid case of selling land. So if we want to buy 10 acres, land price is 20, we have 2,800 acres and 4,000 monies or wheat in store, our return value would be 2810, and the wheat in store would be minus 200, so 3,800. These other cases are for invalid actions. So you can't buy a negative 5 acres of land, so it would return a -1. You can't buy more land than you have money, and so that would also return a -1. This in the test matrix shows our boundaries, which are the max amount of land we can buy with the amount of money we have, and the least amount of land we can buy, which is 0.
Awesome. So step 3 is outline the solution. So in that, we have several things: a summary, a method prologue, and a method signature. In the summary, we say what the purpose of this function is, which is to buy land. Parameters, which parameters are we passing this method, and what the returns is, what are we going to return when this method is done. Conditions, the number of acres to be bought must be greater than or equal to 0, and the cost must be less than or equal to the wheat in store. We have to have enough money in the store. We convert that over to our method prologue. This just goes in our code to tell anyone who reads the code this is what we're doing. Our method signature, so we have a public method. An integer, int, means that we're returning whatever this function returns is going to be provided in an integer. The name is buy land, and then here are 2 variables, price and acres to buy, that we're expecting somebody to pass, or the calling method to pass to us, and they're both going to be integers.
Perfect. So now we would test the algorithm. So using our test matrix here, we'll use some of this information and plug it into our pseudocode, as he was just talking about, and we'll try some of these cases. So let's say, for example, if we had a 10 was less than 0, obviously that's one of the invalid things. So we would skip that, and we would go to the pricing that we have here. So if 2,800 equals 2,800 plus 10, and so you would return 2,810, which is our return value for a valid test matrix.
So basically, we're going through each test case to test our algorithm on paper to make sure everything works great. We have our pseudocode here, which is what we wrote down on paper, and then we have to translate that algorithm into code. So once we put in, we comment out all of our pseudocode, and then we write the code underneath it to accomplish that. So here we initialize our variables. We have an if statement. If acres to buy is less than 0, then we're going to execute the code inside of these curly braces, which is -1. If acres to buy times price, and we do that first because that's in the first set of parentheses. If that is greater than wheat in store, we're also going to return a -1. And then if acres to, once we pass those 2 evaluation conditions, then we're okay to say acres to own equals the acres to own plus acres to buy. So we're adding the acres to buy to our acres to own. So we can do that by either typing it out this way, or we can use this operand of plus equals, and then we actually set the acres to owned in the crop data class to what we've determined that acres to owned should be. Go ahead, Ken.
Right. Okay. And so wheat in store is using the same magic plus minus here, but we're using a minus equals. So we would have wheat in store minus the price times acres to buy, and that would give us our new wheat in store since we just purchased some land. So the set wheat in store for crop data would be the new wheat in store that we just calculated.
So we're actually passing that over to that crop data class. And the very last thing is we return the acres owned back to the calling method. Next is run the test cases to verify the code is working. This is, we have our test matrix, which we did on paper to verify our algorithm was working. Once we put the algorithm into code, we now use test cases and program them in to actually go in and test our code. So here, like for an example, we have, I'll just go over this. We're printing buy land case 1 to the console, which means that way we know that it's executing this code. We're creating a new instance of crop data, assigning it to the crops. We're setting the wheat in store and acres owned of that crop data class to 1,500. Apologize, this graphic is incorrect, but it works just the same as anyway. We declare these variables: price, acres to buy, expected result, and result. We're saying that they're integers. We plug in those numbers, and then we call the function by land. So this is where we're going to take all of these parameters. We're going to pass it to the by land method, and the result that it returns will be put into result. Then we compare. Does the expected result equal the result? If it does, we're good. If not, we get a 0%. And we do that for all of the cases. If all of them evaluate true, then we'll get 100% on our test.
Perfect. And so there's some more test cases there as some more examples, but that is step 6. So step 7 is just deploying those changes once obviously they are working and free from errors. You will push that up to your repository.
So next we want to talk about variable lifespan. There's different types of variables. We have class instance variables, which are have a private modifier and a public getter and setter method, which is one of the, like in the crop class, by land is, or not by land, excuse me, bark and wrong tree, bless you. So we have a private, inside of a class, private integer access or acres owned. And then we have how we can get the value and how we can set the value. So once again, if we call the acres owned, get acres owned method, it will return acres owned as an integer, and we can set it from another method by calling the set acres owned. And this method is looking for the calling method to give it a number, an integer, and then it will take that integer and assign it to acres owned. So then it can be read back in whenever we want to. Creating an instance of this class, we can do it this way. Crop data, which is the class, we're assigning a new instance of crop data to this variable, which has a lowercase, so that they're different. So we can, to get the value, we would say whatever our variable is we want to read in equals crop data, which is this here, dot get acres owned. So we would it would return the value to this here, and to set it, we use this here. The lifespan lasts as long as there's an instance of the variable in use. So effectively, these will potentially last until the end of the program, or till the program ends, or the last reference or instance of the class is closed.
Perfect. Also, a little bit more on variable lifespan. So passing variables into a method. So you can pass variables from one method to another by putting variables in and types inside the function signature. So here's our function signature right here, and we can input these variables in these spots. So we can have a variable named price defined as an integer. Same thing with acres to buy is also an integer. And we can call in an instance of crop data. So the int price and int acres to buy are examples of passing a variable by value. Crop data is passing by reference. So let's say, for example, the variable 10 was price, and 10 was price, and 100 was acres to buy, and this would be passing by the reference.
So one way, once that function signature is set, we can call it by, initializing a variable, which I have a variable here. You're saying that equals crop control by land method, and we pass it a 10, pass it 100, and the instance there. And another example of a variable is instant variables or data members. These variables are used inside a class or methods in a class for reference to the entire class, or inside the method they're defined in respectively. So we set that by, we're saying this variable is private. It's going to be an integer. We can then set it later on in our code, acres to buy equals 50. If these variables are placed inside a class, then the lifespan will be from when the class is called until the last instance is closed. If we're calling it a method, it's when the method ends. And if these variables are defined in an if statement, the lifespan is from when the if statement is started until the if statement is complete, and it doesn't go beyond that. So I wanted to talk a little bit about some of the selection statements that I used in the code. One is a switch case here. The switch, this option is read in above here as to what the user inputted. So if they input a 1, this switch is going to go to case 1, 2, 3, 4, and so on. It would be number 1 would go to case 1, and we would execute the code beneath that. So we're going to call this method here, and then we break. Break will just simply jump execution of code down to here, because we don't need to evaluate all the rest of this because we know it's case 1. If it was case 2, it would go here, it would break and go back down to here and return to our calling function. So another example is an if statement. Its if statement evaluates what's inside the parentheses here. So we have percent off. If percent offering is greater than 0, then we execute this this code that's inside of here. And you can read some of the examples that we have here. Test cases. It's important to have tested the algorithm we created using the test matrix before we code. Then we take that algorithm, we turn it into code, and then we actually write test code in a test class to verify, to actually run the method we created and verify everything. So here we have our test cases, and just show a couple. We have to explain. I think we can go a little bit over. We're approaching our 15 minutes.
Okay.
But I think we can go a little bit over. But so system out, this is just going to print that to the console. New instance of the crops. The crop set wheat and store. We're going to set the wheat to 2,000, set feed the people to 500. These are a variable that we're initializing here. Our expected result is 1,500. Then we actually call the class, pass it the amount to feed people and our instance of the crop data, and assign it to result. If these two are equal, it's good. And this is the example of the code. So we do that for each of these 1, 2, 3, 4, 5, all the way to 8. And if all of these are correct, then it says we got 100%. If not, then we know we need to go back and look at our code.
Perfect. So I did a similar thing to him, switching method for a view. And of course, he had 6 I only had 5 cases, but yep, after each one, if someone types the number 1, it breaks that code and it won't process any more code beyond that point. The next part I did was in crop control. It was the harvest crops method. Mine was a little bit different on his if statements. As Jason already explained, my if statements had a random variable. So the base of the random variable would be 2 and the range would be 4. And so if tithes paid was greater than 12, you could have a potential of 6 as your tithes paid. And so that would be applied to your crop yield, which I'll go over here. Here's my test cases. Obviously, you can see I've got my acres planted and all my inputs and my valid and invalid types. And as you can see, here's an example of me setting that into the test cases with pseudocode and things like that. So if acres planted is 20, tithes paid is 12, and my crop yield would be 5 because 12 is it has a random variable between 2 and 6, so it would be 5, which we would expect to have if my crop yield is 5. The expected result would be 100, and so that would be perfect, and it would go into the code and would come back as positive, so we're good there. So what I actually did is we went in and we had to add each if statement separately for each one of the possibilities for the randomness of my code. But as you can see, it's possible and it's a lot of fun. Back to you, Jason.
So thanks. That's our presentation. I will send you a link to a longer version of this if you want to hear a little more in detail, but thanks for your time.
Perfect. Thanks.